Okay, we're looking at analysing data. So we'll look at the 5 main methods that we have for this, and then we'll do a couple of exam style questions at the end. So let's say we've done a hot dog eating contest, and we've recorded the number of hot dogs eaten per person in 1 minute. So we've got 10 people have taken part in this contest, and so like 2 people have eaten 4 hot dogs, 2 people have eaten 5 hot dogs, 1 person's eaten 6 hot dogs, etc. And we've kind of listed all of our hot dogs eaten in order. Well, let's first look at the mean. So let's first look at the kind of the mean number of hot dogs eaten per person. Well, the mean we can remember is called the mean because it's the meanest one to calculate. It takes the longest amount of time. In this case, what we do is we have to add up all of our numbers and then we divide by the number of numbers or the number of data points. In this case, we've got 10 data points, right? We've got 10 people taking part in the contest. And so we first add up our numbers. Well, that's going to be 4 plus 4 is 8, plus 10 is 18, plus 6 is 24, plus another 21, that's 45, plus another 16, that's 61. So our total number of hot dogs eaten between our 10 people is going to be 61 hot dogs that they've all eaten together. Well, if you want to work out the number of hot dogs eaten per person on average, we just take that total number of hot dogs and we divide it by the number of people, which is 10 in this case. And so we know the average person has eaten 6.1 hot dogs, right? 10 of those people would give us 61 hot dogs. So our mean is 6.1 hot dogs. Let's look at the median. So the median is the middle number. Well, you'll see here that we don't really have a middle number, right? We've got 5 numbers here, 5 numbers here. We don't have this middle number. We're missing this middle number. Sometimes textbooks are quite nice and they'll give you an odd number of numbers. I haven't been quite so nice here. Well, what we do in this case is we kind of make up the data, right? We say, well, what number would be here if there was a number here? And we know it's going to be bang in the middle of 6 and 7. And so we say the median is going to be 6.5. We just split the difference between 6 and 7. And there's a formula that we can use as well. So the formula is we take the number of data points, we add 1 to it, and we divide it by 2. In this case, that's going to be 10 people, add 1 is 11, divide that by 2. Well, 11 over 2 is just 5.5. And so again, the formula tells us that we look at the 5.5th person. And so we go along 1, 2, 3, 4, 5.5 people. And again, the formula tells us to look, in this area to find our median. Let's look at the mode next. So the mode kind of rhymes with most, right? It's the most occurring number. Well, if we look at our data, we've got 3 7s, right? We haven't got any more of any other number. And so our most occurring number is going to be 7. So there are 3 main ways of calculating the average, right? We've got mean, median, and mode. We can kind of split this down the middle, and we'll now look at the range and the lower and upper quartile. And these are kind of no longer really related directly to the average of our data. So the range is very simple. It's just the maximum minus the minimum. In this case, the maximum is going to be 8, and the minimum is going to be 4. So 8 minus 4 gives us 4. So there's a range of 4 hot dogs. The fastest eating hot dog eater has eaten 4 more hot dogs than the slowest hot dog eater. Let's look at the lower and upper quartile. So the lower and upper quartile are very similar to the median. The median is the very middle. It's 50% of the way along. The lower quartile is 25% of the way along. So the lower quartile is just the number that's 25% of the way along. Well, if we look at this, it's halfway between our first half, right? The number that's halfway between our first half is that 5 there, isn't it? We've got 2 either side of it, 5 bang in the middle, and so our lower quartile is going to be 5. And likewise, in our top half of our data, we've got this 7 bang in the middle of this top half, and so our upper quartile is going to be 7. Our interquartile range, which sometimes we can be asked that as well, right? Interquartile range is just going to be our upper quartile minus our lower quartile. In this case, that's going to be 7 minus 5, which gives us 2. The interquartile range is just a way of kind of looking at how grouped together the data is, right? So in this case, it's fairly grouped together. But if we were to say look at the heights of students in a class, Well, we may have one class where all the students are very, very closely grouped together. On a graph, we may have most of our students are around 1.6 meters or something. Most are kind of appearing in this gap, and there are a few shorter students and a few taller students. That would have a very narrow interquartile range. If we had another class where we had lots of much more discrepancy in our heights, we might have a graph that looks more like this, way more spread out, and so our interquartile range is going to be much wider. And so there are still a few short students and still a few tall students, but a much wider range of our students are in this interquartile range. So it's a very convenient way of looking at how spread out our data is. Let's look at some exam style questions. So what is the mode of this data set? Well, the mode, again, is the most occurring number. In this case, we've got a 3 here and a 3 here, and so I know my mode is going to be 3. The range of the data set, again, it's the maximum minus the minimum. In this case, it's going to be 10 minus 1. 10 minus 1 will give us 9. So 9 is our range. Finally, Bob says, from the table, I can tell that the median of the data is in the 7 to 9 class interval. Why is he incorrect? So he's incorrect. Well, there's a couple of different ways that we can understand this, right? So, the table's already done half the work for us, really. It's kind of put it in order already. All right, we've got this could be, for example, lengths of a piece of string, to keep it super simple. We've got 4 pieces of string that are maybe 1 to 3 centimeters long. We've got 6 pieces of string that are maybe 4 to 6 centimeters long, and so on. And we want to find the very middle piece of string. Where does that lie? Roughly, what's the length of that piece of string that's in the very middle? If we put all of our lengths out from smallest to longest. Well, if we look at how many pieces of string we've got in total, just continuing this piece of string analogy, we've got 4 plus 6 is 10, plus 1 is 11, plus another 4 is 15, plus 2 is 17. So we've got a total of 17 data points, or 17 pieces of string in my example. And so we know that we could shove it into our formula if we wanted to, right? Our median point is going to be n plus 1 over 2. In this case, it's 17 plus 1 over 2. Well, 17 plus 1 is 18. And half of 18 gives me 9. And so I know the 9th number will represent my median number. Well, the 9th number occurs in this class interval, right? We've got 4 numbers in the first one and 6 numbers in the second class interval. And so it's the second to last number in this class interval would represent my median. Another way that we can understand this is, if we just kind of estimated the lengths of each string. Let's continue this string example. So let's say, rather than 1 to 3, we're going to estimate and say all the pieces of string in this class interval are 2 centimeters long. And so we would have 4 2 centimeter long pieces of string in that class interval. We then have 6 pieces of string that are roughly 5 centimeters long. So we're going to have 6 5 centimeter long pieces of string. And then we're going to have 1 roughly 8 centimeter long piece of string, 4 11 centimeter long pieces of string, and 2 roughly 14 centimeter long pieces of string. And so again, we've got 17 pieces of string overall, and we want to find the very middle one, right? So we know that we can kind of count along 8 from the left, which is going to be that. We can count along 8 from the right, which is going to be that. And the middle number that's left, that middle number there, is our median, right? That 5 is in our 4 to 6 class interval. And so that's another way of thinking about this. It's just the very central number if we put all of our numbers in a long row. I've just estimated all these string lengths just to prove a point. But that's kind of what's going on behind the scenes when we use this formula. Hope that makes sense. That's the end of our lesson, and that's the end of analyzing data. So hopefully that's made a bit of sense.